Hello everyone, this is the Emptiest void, nicknamed the Great Nothing, the single most vacant region in the entire observable universe, a vast spherical abyss, where matter, radiation, and even the faint hum of cosmic energy all but disappear. For billions of years, this colossal expanse has sat undisturbed, a blank canvas in the sky that reveals the hidden rules of cosmic structure, gravity, and the evolution of everything we know. To stand at its center would mean looking out in every direction and seeing almost nothing. No bright stars, no swirling galaxies, no glowing gas clouds, just an endless cold darkness that stretches farther than the human mind can possibly grasp. This is not a black hole, not a nebula, not a distant star cluster. It is pure, unadulterated emptiness, and it is one of the most profound discoveries in the history of astronomy. Long before we found this void, astronomers believed the universe was spread relatively evenly, with galaxies scattered gently across space, like stars in the night sky. That all changed in the late 1970s, when teams of scientists began using redshift surveys to map the three-dimensional structure of the cosmos. Redshift, the stretching of light waves as objects move away from us, lets astronomers measure distance and map where galaxies lie across deep space. In 1978, Stephen Gregory and Laird Thompson made the first groundbreaking discovery: large empty regions separating dense filaments of galaxies, a structure we now call the cosmic web. But nothing prepared the world for what Robert Kirshner and his team found in 1981 while surveying the constellation Emptiest. They expected a standard spread of galaxies, but instead, they found a gaping hole in the cosmic map, a region hundreds of millions of light years across, with almost no galaxies at all. They published their findings in a paper titled "A Million Megaparsec Void in Emptiest," and the world of astronomy was shaken to its core. The Emptiest void was not just a small empty patch. It was a supervoid, a titanic expanse, that defied every prior expectation of how matter was distributed in the universe. Let us put its size into perspective, because numbers alone cannot capture how truly immense this void is. The Emptiest void has a diameter of roughly 250 million light-years. To cross it at the speed of light, 186,000 miles per second, would take 250 million years longer than the time it took for complex life to evolve on Earth. Its center lies about 700 million light-years from Earth, far beyond the reaches of our local galaxy group, and even the nearby superclusters. In a volume this enormous, cosmic averages tell us there should be at least 2,000 galaxies packed into filaments and clusters, just like everywhere else in the universe. But after decades of careful observation with ground-based telescopes, the Hubble Space Telescope, and now the James Webb Space Telescope, astronomers have found only 60 galaxies inside the entire void. To put that into human terms, imagine a massive stadium built to hold 10,000 people, but only 6 individuals show up, scattered so far apart that they cannot see or hear one another. That is the Emptiest void, a cosmic stadium built for thousands of galaxies, occupied by just a handful, floating alone in the dark, like tiny islands in an endless ocean. These few galaxies are not spread randomly either. They form a thin tube-like filament cutting through the void, a faint leftover thread of the cosmic web that barely survived the void's formation. What makes the Emptiest void even more extraordinary is not just its lack of galaxies, but its near total absence of ordinary matter and radiation. In normal intergalactic space, even between galaxies, there is a thin haze of hydrogen and helium gas left over from the Big Bang, along with cosmic rays, microwave, background radiation, and faint emissions from distant objects. Inside the Emptiest void, this diffuse matter is diluted to an extreme degree. Its density is just a tiny fraction of the universe's average density, as low as 1/10 to 1/100th of what is normal. The cosmic microwave background, the faint afterglow of the Big Bang that fills every corner of space, is slightly cooler and more uniform here, with fewer disturbances from dense matter or energetic events. Radiation from distant quasars and galaxies passes through this void with almost no interaction, as if traveling through a perfect vacuum. There are no stellar nurseries, no supernovae, no black hole mergers, none of the dynamic events that light up the rest of the cosmos. This is a place of perfect stillness, a cosmic graveyard, where the energy and activity that define our universe have been almost completely erased. To understand why the Emptiest void exists, we must go back to the earliest moments of the universe, just fractions of a second after the Big Bang. At that time, the universe was a hot, dense soup of particles and energy, almost perfectly uniform, but not quite. Tiny, quantum fluctuations created microscopic variations in density. Some regions were slightly denser, others slightly emptier. As the universe expanded and cooled, gravity amplified these small differences. Denser regions pulled in more matter over billions of years, forming the filaments, clusters, and walls of the cosmic web, the bright, busy structures we see today. The slightly emptier regions, however, lost matter to their denser neighbors, growing more and more vacant as time passed. Small voids merged into larger ones, and over 13 billion years, the largest of these became supervoids, like Botes. This process, driven by gravity and cosmic expansion, is described by the lambda CDM model, the leading theory of cosmic structure formation, and the Botes void is one of its most dramatic proofs. It is not a scar, not a wound, not a sign of destruction. It is a natural product of the universe birth and growth, a blank space that reveals how the cosmos builds itself from tiny quantum ripples. For astronomers and physicists, the Botes void is far more than a curiosity. It is a priceless scientific laboratory, a place where we can test our most fundamental theories about the universe under extreme conditions. Because it has so little matter and so little interference, it lets us study cosmic expansion, dark energy, and gravity without the noise of dense galaxy clusters or turbulent gas clouds. Dark energy, the mysterious force driving the universe's accelerated expansion, acts more clearly in voids where gravity is too weak to counteract its push. Measurements inside the Botes void help us refine the Hubble constant, the number that describes how fast the universe is expanding, and ease the tension between different measurements that has puzzled astronomers for years. The void also preserves clues about the early universe's quantum fluctuations, the seeds from which all cosmic structure grew. By mapping its shape and density, scientists can peer back almost to the beginning of time, learning about the conditions that existed mere moments after the Big Bang. The Botes void also forces us to rethink our place in the cosmos and the rare luck that allows life to exist on Earth. We live in a relatively dense part of the cosmic web, surrounded by galaxies, with a steady supply of matter and energy that allowed stars, planets, and life to form. If our solar system were inside the Botes void, we would barely know other galaxies existed. The night sky would be almost completely black, and we would likely believe the Milky Way was the only galaxy in the entire universe. Our understanding of cosmology, of the Big Bang, of the universe's structure, would be completely wrong, limited by the utter emptiness around us. This void teaches us that the universe is not just the collection of bright objects, but a vast landscape of structure and emptiness, where most of the volume is silent and dark. It reveals that the busy, bright parts of the cosmos where we live are the rare exceptions, not the rule. Most of the universe is like the Botes void, empty, silent, and invisible to our eyes, waiting to be explored and understood. Over the past 40 years, our study of the Botes void has evolved with our technology. Early observations could only confirm its existence and measure its rough size, counting the few galaxies that broke through its darkness. Modern telescopes, like the James Webb Space Telescope, with its infrared vision, can peer deeper into the void, detecting the faintest gas clouds and mapping the distribution of dark matter within it. Dark matter, the invisible substance that makes up most of the universe's mass, is present in the void, but at extremely low densities, and studying it helps us learn how dark matter behaves in the quietest corners of space. Surveys like the Sloan Digital Sky Survey and the Euclid mission are mapping millions of galaxies to trace the edges of the Botes void and other supervoids, building a complete picture of the cosmic web and its empty spaces. Every new observation brings a new surprise, a new clue about how the universe works at its largest scales. As we stand at the edge of this cosmic abyss, we feel a profound sense of awe and humility. The Botes void reminds us that the universe is far larger, stranger, and more wonderful than we can ever imagine. It is easy to focus on the bright, beautiful objects that fill our telescopes, the swirling spiral galaxies, the explosive supernovae, the delicate nebulae where stars are born, but the empty places are just as important, just as meaningful, and just as essential to the story of the cosmos. The great nothing is not a void of meaning. It is a void of matter, a blank page that lets us read the universe's most fundamental laws with perfect clarity. It is a testament to the power of gravity, the legacy of the Big Bang, and the mysterious dark energy that will shape the universe's fate for trillions of years to come. Please like, comment, share, and subscribe to the channel.